Good morning to the participants. So I do see some familiar faces, I think, but of course many of you I don't know yet. As indeed, maybe, okay, I'll better maybe go on with what I thought we'll do today. I understood that you have, of course, some of you have attended last week as well, so you know a lot about what agent-based modeling is in general, and you actually have hands-on experience with the coding. And I understood that you started with working with empirical data yesterday and learned some main concepts. So first of all, I wanted to tell you, so please do not hesitate to interrupt, ask questions, raise comments during the talk, and of course after. But first of all, I wanted to understand a little bit maybe the type of models you're working on. I guess you all have some interest in agent-based modeling, and some of you probably have a particular project within your PhD or master or just a research project you're working on. So I just was wondering whether you could maybe mention some of the topics that you work on so that I can relate better also when I go through the examples. Guys, so what do you work on, and what's your background discipline-wise? So, do you like
sign language emergence, and sign language evolution?
Oh, nice.
My background is in resource management, and I'm mapping resource flows and communities and engaging with civic
Resource management. So,
I'm also doing a PhD in Delft.
Speak loud, please.
What's that?
Energy transition.
Energy transition, yeah.
So.
Hi, my background is in maths and epidemiology. I'm model health systems to optimize intervention within hospitals and health.
Yes, clear. Yes.
Mine's in sociology, network sociology, and it's like a spread of information type of study that I do.
Diffusion of information.
Yeah,
Yes.
exactly.
And
my background is in geography, and we try to model investment decisions in circular economy technology.
Great.
My background is in computational sociology or social science, and my model should be opinion dynamics.
Opinion dynamics, yes.
I'm a doctoral student in public policy, and I'm working on adaptation to climate change and conflict.
Great.
I'm a sociologist, and I basically study student social networks.
Yes.
I'm working on gender stereotypes in STEM disciplines.
All right.
I'm concerned with the management accounting research field, and I want to look at how social norms evolve in a budgeting setting.
My background is in philosophy, but I'm doing PhD in sociology about the norms of speech regulation.
Speech, yes.
I'm working on developing and sociology, and it's my research topic is like fertility and mortality in historical periods.
Yes, clear. Thank you. Just the last row.
Yeah. My background is in sustainability, and I'm similar to Steve doing diffusion of circular economy innovation.
My field is behavioral economy, and I focus on repeated game theory and social distances and measurement in distances information.
Thank you.
Hi, my background is mainly in psychology, and my study is related with the cognitive system. I try to represent the cognitive system and model how it interacts with other agents within the social network.
Okay, nice. So,
Hi, my background is in environmental engineering mostly, but I'm now doing a bullying model.
Hi, my background is in biology and animal behavior, so I started doing models of primate social behavior. Now I have moved into human social simulations. Now I'm involved in two projects. One involves integration of minorities, and the other one spreads of religious beliefs.
great. Thank you.
Hi, Tatiana. My background is environmental science. My main focus is to
use environmental system dynamics or socio-ecological dynamics to understand the limits of sustainability across different scales.
Great, thank you. So nice to see you again. So, thank you for sharing. So I'm asking because I would like to understand, so of course the audience and the type of examples and how much I need to explain maybe from what I will go through. So I myself, I'm an environmental economist by background, and I use a lot of agent-based modeling in the projects that we work with. Not only agent-based modeling, but it's, I guess, my favorite research method. And I work a lot in the domain of climate change, a lot on the adaptation, somewhat with mitigation, but we do use opinion models and diffusion of information, some psychological concepts in specifying behavioral rules of agents. So I have never worked with languages, but I think if we may see that perhaps as something like as an emergence of some common norm, or as I guess you may relate as well. So, so you probably do. How many of you do not use any empirical data in your models, in your research projects? So you all work with empirical data? Yes. Okay. More or less. So is it usually the data on the micro level? So do you collect data on the individuals, or do you work primarily with the aggregated data? Individuals. Great. So so, of course, I think yesterday especially you have learned already some things about agent-based and data. And so when do you use, of course, there are different types of models. So from what you have learned yesterday, when do you use really, you went through all the range of models, I understood, where you go from case-based to really toy models. So of course, it depends on whether you use data in your agent-based model or not, and where, and for what purpose. Of course, depends very much on what's the purpose of your model, first of all. Is it something that is meant to enable learning among stakeholders? Does the model serve a purpose of exploring something hypothetical, maybe testing some theories, or is it about prediction? Or is it still for policy advice, but in the exploratory manner? So we do not predict exactly what happens, but we try to understand the range of scenarios and whether they end up in one or another domain of outcomes. So, of course, when we deal with agent-based models, that I think you also have learned already. So, of course, when we deal with the core of any agent-based model is that practically we are trying to specify some rules guiding behavior of individual agents and interactions among them, possibly their learning, how they adapt as well, and we try to observe what the emergent properties are. And it's very crucial what sort of micro foundations we are putting into this, because it defines everything on this side, more or less. And we normally use both theory and data. So on that range from toy to fully empirical predictive models, there is a lot that can be done. But very often, in either way, even with very empirical models, we still try to relate to some theory because it guides the type of research questions common in our discipline. It allows us to communicate results and to relate to other, also non-IBM literature in the field. But with the data informs practically, of course, the rules, not only the parameters, so you also went through parameters yesterday. It informs the parameters of the agents, but also rules. So what exactly do they do? So we can, especially a lot of qualitative data can be put in defining the process of decision making. But it also can serve to understand whether the model is reproducing any of the empirical trends or patterns observed. Of course, data traditionally has been used to test different theories, and theories were used to guide data collection. So, but on this range, so of course, when we deal with data, we are trying to collect it from different types of sources. The one that I have dealt primarily in my work would be either on the more aggregated level, so when we would deal with some market data, with GIS data or census data. Of course, usually it's a rather aggregated set. We do not have really specifics about individuals. We also deal with quite some data that are collected on the micro level. So I work primarily with surveys, I should admit. So I did try lab experiments, and I will reflect on this. So with colleagues, I have not done participatory modeling myself, but I have worked on several projects with colleagues where they either ran a sort of a role-playing game or a completely open participatory workshop where stakeholders' decisions were mapped in terms of cognitive maps, for example. And more recently, there is more and more attention towards the use of social media data, as well as data collected through different mobile apps to specify the actions, not only parameters, but also the types of decisions we make as people. So, of course, sorry, it's the wrong way. So, of course, this is sort of the data, the type of data we are collecting on the system level that can help us either test, compare the emergent properties from our model with the real world, or we can also use the agent level data for specifying the micro foundations. Another thing which I would like to pay your attention to before we go, I would like to show you some examples, is of course that we deal with complex adaptive systems. Otherwise, so with everything more or less that we deal with, especially if it's about social systems, we are constantly more or less changing. There is something happening all the time. And the only question is, what type of change are we dealing with? Is it some sort of marginal change along the same line where we could, in fact, rely on historic data and try to extrapolate the trends and with confidence use it also in our models? Or do we, but we also know that there are a lot of cases where more abrupt non-marginal changes occur in regime shifts and so on. So it's more and more documented, not only, of course in social ecological systems, but also in purely social systems, like take the financial crisis or run on a bank, or any of the social political shifts in the recent years. So we do experience this, which means that we sometimes have to deal with the system and are studying and modeling systems that in fact change states. And that has a lot to do, and that has a lot of implications for the type of data we collect, because obviously we cannot rely on that data when we are studying this process, on this data alone. So when it comes to data, a lot has been written already and said about this in the agent-based modeling community, starting from the early work when people were trying to understand, so, okay, if we would like to have empirical models, what type of data can we use? How do we parameterize? How do we validate? And what sort of methods we can use? Of course, back then it was a lot written about the type of validation and how you parameterize. What do you do? For example, if you run a survey, how do you instantiate the artificial population in your model? Do you do it independently or dependently? Let's say if you have a data on the incomes and on the size of plots the farmers have. How do you match it together? So because you have to instantiate both in the model. So there are a lot of tricks already and do's and don'ts developed on this side. Further on, there have been several reviews that are reviewing the best approaches in the agent-based literature on what type of data you could use. But for example, Derek Robinson already some 12 years ago have written a paper where they tried to collect, to understand how do you use different types of data. And the only thing which I would like to bring your attention to at this moment is that there are a lot of data that just collects data points as a snapshot in time, which is okay, and that's very often what we have to deal with, but it does miss any potential dynamic in the social system. So if we are interested in anything related to behavioral change and learning, or anything related to these abrupt changes. We might not capture it if it's just a snapshot, obviously. Later on, there was another review done by Alex Majgl, who also reviewed different methods, and they classified it a bit differently. And they have provided a guidance: what do you do, what sort of steps you take, what type of data do you use for what. So there is a lot written as well. And of course, again, we are talking about the data that is collected as a snapshot in time versus something that can reveal the dynamics potentially. And more recently, Andrew Bell sort of have written an update on this, discussing the use of not only a bit of social media, but practically the use of mobile apps to collect data through micro-surveys. So instead of having a survey, which was usually done, or first on the paper version or telephone, then later on online surveys were run, but it was still one-time survey. Now what you could do, in fact, you could interview people on a weekly basis or a monthly basis with very small questions, and you could trace this, their decision-making over time. So this is and you could obviously use it in the agent-based models. So this is something that is emerging, as well as the use of social media. But so what I wanted to, of course, to bring your attention once again, so when we talk about moving towards empirical models, there is, of course, data that we could use either to specify something at the level of an agent, and the most obvious and the most often used thing is to specify something on the parameters, let's say incomes, norms, preferences, perceptions, anything that that matters for the type of decisions that you're trying to study. But it's much more difficult, but extremely important also, to understand how decisions are actually made. So what sort of data can you use to validate or parameterize the rules? So how do agents act, in fact? Is it something as the theory predicts, or is it somehow, when we actually bring it in the context of a particular case study or particular problem, maybe not even a case study, but something in the middle range, you sometimes need to adjust it. So the rules of interaction, so if agents do interact with each other, let's say they exchange information, especially in the information diffusion models, the speed of information exchange would impact the results of any model, more or less. And the differences can be qualitative, so it's not just how quickly it reaches, but the curve could be completely different. So you might want to understand whether actually the type of interactions, the speed of interactions matter. And how do they learn? Because, of course, we use agent-based modeling to understand how adaptive agents make decisions, right? So, but then how do they adapt, in fact? What is it what they are learning about, and what is changing on the agent side? Do we have any empirical evidence on this? At the macro level, so this is something what is very often used for validation. So we are trying to do whatever on the micro level, so put the micro foundations, and then try to understand whether our model is reproducing the patterns observed. But you also could use some aggregated data to specify something in the agent's population. Of course, with the census data, it's very common to use incomes and distribution of the population if that's of importance. Or any social values surveys can also provide some information on a rather aggregated level, which you could disaggregate. But of course, and the types of data. So I have mentioned already several, and there is more. I'm quite sure I might have omitted something, but especially I think I put everything related, so it should be stakeholders here. So because there are different ways of working with that. So, and how I suggest to proceed with further. So I would just like to quickly tell you a bit about, so that you know the background where I'm coming from as well. So about the topics that I'm working on, and I would like to show you some examples going through these different types of usage of data in the agent-based models, the data coming from different types of sources. And I would like to finalize also at the end of the lecture with some lessons maybe from my side, so what I find useful or not useful by using different type of data for different types of purposes in the agent-based model. So I work a lot on the, as I mentioned, on the climate change domain, and I'm interested in how behavioral change at the micro level actually, how can we quantify, if we understand how behavior is changing, can we actually quantify the consequences for a larger group or region? And I work on, in the domain of floods or droughts, but also we had some projects related to energy and what households can do on their own side, how households can change behavior, and what does it imply in terms of saved CO2 and so on, so that you could relate it to the energy transition. So let me just talk you through the first example a bit, and then I will discuss, and that's the one where I think I worked a lot, and that's where we used different types of data. So this is the project that has already started in 2012, so, and there have been different people working on this, and it's a part of a bigger team effort, but we did use different types of data there, and I just wanted to maybe share with you the pathway that we went through and where we did get stuck with a particular type of data and what we did do further. So the problem was about the problem there was about the fact that with climate change we had to experience more severe and more frequent flooding, and but at the same time a lot of our cities are close to the water for historic reasons, and that's where they grow, and urbanization rates are so rapid in the current years that we are to expect even more people and capital to be placed in the areas that are actually flood prone. So, and we were trying to understand where the individual risk perception, for example, has a role here at all, because if we are talking, especially if we are talking about climate adaptation, combining private and public, private meaning that individuals can do something on their own, it means that they have to understand these risks in the first place. So, and that's where we were looking at. And with this project, eventually we worked a lot with the US data, because it was available. A lot of things were already available at the beginning. And what we do know also about the processes there is that people do like, of course, to live close to water. And from the empirical data, we also know that, the houses cost much more if they're close to the water, so it's sometimes 30% more on top of the normal price of an average price of a house if it's close to water. But these amenities are spatially correlated with risks, but the risks, and if a house is also flood prone in principle, there is a price discount, so the price is lower. But this price discount is very small. And what we also know is that it changes over time. So just immediately after a hazard event, the prices for houses that are hazard prone do fall, but people forget, so within 5 to 6 years in the US, this price discount disappears, meaning that there is some sort of dynamics on the risk perception side. And what we also know that is that if the risks are increasing, we are to expect even people live in these areas, either in a planned or unplanned way. So what we did here, we developed a spatial agent-based model, and we had used a lot of data in terms of GIS data, for example. And we did model specifically, so I started with modeling the entire market. So we had buyers' behavior, sellers' behavior, they would meet, they would negotiate the price, there would be a transaction, and then the price expectations would adapt, and so they would go on. And we were running different experiments on this. And in this project we used, so coming back to this picture, we used all sorts of different types of data. So actually we did a lot on the micro level. We also tried to compare it with all sorts of aggregated data we had, and through different means. And I will talk you through this a bit, and in terms of our experience. So we started, of course, the most simple one was that we needed to parameterize something on the side of buyers and sellers, so we wanted to look first at the data that is available. And of course that was the census data, and we could specify such parameters as income or share of income spent on housing, for example, because there were surveys run already on this on the national scale. So we could also, of course, have the distribution of income in a particular area, so, and they would change over the area. So that was relatively straightforward, I would say. We also used a lot of data on the goods themselves. So the houses people were trading, agents were trading, were heterogeneous. And we use market data. So we had actually transactions from this area for about 17 years with 2 hurricanes in between. So we could see exactly this change in the perceptions levels. But what we did not know, in fact, when I started first with this model myself, I thought, okay, because it's a housing market, let me start from the theory, and the best theory that is guiding this process comes from urban economics, where we have, of course, this rational agent, with perfect information, and so on. Of course, we tried, but very quickly I realized that doesn't work, of course, in this context, and then we need to put some bounded rationality. And then the question was for me, but where does it come from, and how do they actually make these decisions? So eventually, what I did do first, I ran semi-structured interviews with several real estate agents, because I wanted to understand how do actually we do know that the flood risks enter rarely in the decisions about where to live, but I wanted to understand still how does this happen? Is this happen? So how do buyers make decisions? How do sellers make decisions? So how actually realtors are learning about prices? So to specify these processes in the model, and that helped a lot. So in that sense that I could get the sequence of actions, what influences a decision, and how price negotiation was actually happening. So it was, of course, further away from the theory, and because we also had to come from a perfect one-shot equilibrium into a process of how this price is achieved in this case. So that was quite useful. We also had, in addition to the semi-structured interviews, I worked with the market data. So where we could, for example, it was the prices for each parcel with all its attributes. So we could actually construct a aggregate demand curve here. So it's practically what an average buyer would buy. So how much would average buyer pay for a particular house, given that it has that many rooms and it's far away, that far away from something. Yes?
You mentioned that you looked initially at the urban and economics literature, and then kind of transitioned to just focusing on the micro level data. I guess in terms of like a starting point, what is better? Is it to kind of dive into the literature and the theory first, or kind of just dive into the actual situation in reality? Because sometimes with a lot of the theory, it's more macro scale, and they don't really capture some of the things you need to understand the micro scale, I guess.
I guess there are 2 points. So the first, the transition from theory to the empirical model, and the second one, where the theories are on the macro scale. I think there are. Maybe I'll start with the second. So there are several theories, I think, especially if you go into psychology, right, that would actually define a very detailed stages of a particular cognitive process on a micro level. So there are a lot of theories, but the problem there is that there are too many theories. They all talk about very similar things, and then it's not clear whether you first of all, the first question outside ABM, whether the theories are validated, but the second question, if you deal with ABM and theory, is that whenever you need to translate a particular theory about human behavior that uses some qualitative concepts, for example, like social norms, perceptions, and even perceived behavior control, and so on, you have to put that somehow in the formal code. And it's a qualitative concept, and how you interpret it and how you put it in the code can actually have a difference. And I'll return back to that at the end of the talk. But from my experience here, so I started, but I actually did keep the link to the urban economics in some way, in the sense that, in this particular case, this theory says that practically just people have preferences and they make choices constrained by their budget. So they have a particular budget, and within that budget they try to find the best house, in this case, possible. So I still have in the model the budget, and they cannot go beyond the budget, and they still try to choose the house that fits their preferences, but they're not optimizing anymore. And the decision is not anymore just I go and look, but it's I go look and I submit a bid, but then my bid may not be selected. So, and then I need to go to try another time, and then I may get not the house of my first choice. So in that sense, so I sort of disaggregated that in steps. Are there any other questions at this stage? Thanks. So. Anyways, just to mention, so with this, we worked with this market data in the sense that we could try to understand how an average buyer makes a decision on this, in this situation. But of course, we didn't need the average. We need a particular buyer and some with, and we were interested in the biases in risk perception. So because people perceive risks differently, information about risks diffuses and actually can impact these decisions. So we went also further into trying to understand. So, but first with this. But this macro level data, actually what was very useful about this, we could understand what would be this price discount. We could estimate empirically how much prices will drop, and then we could test alternative theories defining behavior under uncertainty, for example, under risks in this case, and try to understand which of them. We did not know yet, we didn't have any data on the micro level, except the census data that specified the incomes. But we could test already the theories and compare which of the agent-based models specified with the particular theory would produce the outcomes that is closest to the aggregated data we could find. And that's what we did as well. So this was the work of my PhD student, Kuhn. So what Kuhn did, he actually looked at different theories. So we still didn't have that much data on the micro level here, but we did know that the price discount we should arrive to should be within a particular range, which was empirical. What we could, so we tested, we did not also have any data on the, let's say, how much they prefer amenities and this sort of things, which we just cannot extract easily. So but what we could do with the model, with different settings on the preference, and different theoretical models behind the decisions, we could produce these prices, all sorts of different price trends. And then we could extract statistically from that what is actually the price discount under different conditions. And that we could already, so this would be the price discount under different runs. I omit the details, but the only thing which I would like you to pay attention at is that, for example, this would be the expected utility theory under different settings with the sensitivity analysis for the preferences for amenities, which was important in this case for us. So, and we could then identify which of them, so this was prospect theory, and this one when people were not perceiving risks at all. And then we could compare which of these bars was actually closer to the reality. So our outcomes here were that while we do know actually that people do not behave as expected utility people, they are more prospect theory. So, and that's the more psychological, of course. It's where we know that the probabilities are weighted, that there is a loss aversion, and all sorts of biases enter this picture. We actually found out that on the aggregate level, if the market is involved, the prospect theory overestimates the price discount. So that was maybe a disappointment for me because I really wanted that to win, but it didn't. But what we did find as well is that expected utility probably was the closest, but it underestimates the risk. So it was somewhere in between. So it was, of course, unsatisfactory, and we didn't know, and mind that we didn't have any data here. That's why we went a bit further and wanted, so my first quest was to understand, of course, we do know that these perceptions differ across people, and we do know that they change. So I think that had to make a difference here. And what's expected, so what's expected here, so I'm just trying to show you the picture of that aggregate price. So conceptually, it's perceived that if, let's say, if this is the normal price of the house, this is the price of the house in the flood zone. So then after the hazard event, it drops, but over time it goes up, and then it drops, and then it goes up again. So that's what actually happens in reality and in theory as well. In the model, if we do run it, so our drops are very abrupt, so the price falls very roughly down, and then it comes back very quickly. So obviously, we needed some information on how people learn, how they perceive at the first place, and how they learn in a group as well, because they do learn in a group. And my first attempt was to go then and try to understand whether we could actually extract the dynamic information on the dynamics of this process through the lab experiments. And that's where we collaborated with the London School of Economics in Vienna Center for Experimental Economics. So, and we designed, and first I came with this empirical problem to experimental economists. And we tried to design an experiment that would fit it as much, would fit my empirical problem as much as possible. Very quickly, I realized that there is actually no such experiment, so we had to play a bit with the asset market experiment. I don't know how many of you are familiar, but there is a standard experiment with which we had to adjust. But the problem in my empirical case was that practically I had to understand how people treat a loss, a big loss with a small probability. And the small probability in the real case was, let's say, once in 100 years. For the lab experiment, it meant that we had to run the experiment 100 times roughly to reproduce their probability one-to-one. And that's not possible in experimental settings where you at max maybe have 15, 20 runs in a go. So we had to adapt the probability to once in 10 and then still run it in the experiment, which was a lot of fun, I should admit. So we had a lot of fun. And we could also see, we did test different options also when people, when there were no group interactions or when there were group interactions. And we also added bargaining on top, so sort of something to negotiate the price down if you understand the risks. And what we do see as well is that depending on the setup, the prices, so this is the plotted price from the experiments, we could see that they either blow up, it's getting blown up or not. However, for me, it was too stylized to use in the model further because, and the problem was these probabilities. So because eventually the experiment was run still for the types of events that were rather frequent, so once in 10 times. And the loss was in the experimental settings was you cannot really lose as a participant of the experiment. You cannot get robbed, right? If you participate in the experiment, well, we had to really, but that's what have been happening in reality. So for this, so sort of this branch of the research did get frozen at the moment in the sense that I realized that we need just a different type of agent-based model. So we cannot use this experimental data in the real market model, but it would be still, I think it's still an exciting opportunity to go on with this data and to try to understand what actually happens if we do observe the patterns that are in the lab, and what happens if there are actually more agents trading given these rules. So for me, it means that a different model had to be coded. But so if there is anybody interested in the experiments, I would be happy to discuss this as a collaboration. So, but for me, so that meant as well that I had to stop with the experiments, and at that point, Koen, the PhD student, we decided that he will run a survey. So, and he did run a survey among buyers and sellers, so now with a large sample, and we wanted to understand and so to capture actually different behavioral biases. That's what we did. And from this survey, he was trying to understand what sort of concepts are shaping the decision of buyers versus sellers on this market, because they had access to different type of information. So there was information asymmetry as well. And how does this information further can influence the decision? So, and he was trying to, so the green arrows here show that there is a positive effect, and the thickness of the arrow means that it's stronger. The narrow arrows means that the effect is small. The red arrows are the negative effects. So what we could see is, for example, if the person was had been experienced flooding, there would be fear towards this event, and that fear was a very strong explanatory variable to avoid flood zones, for example.
How did you calculate the size of the effects and the positive, negative, from the survey?
From the survey, so Kuhn did run a lot of statistical analysis on top of this, and he used Bayesian statistics on top. But what we also found out that this decision model is different for buyers compared to sellers. So, of course, the next step for us was to try to do that in the model, because if we have now the data on the micro level, and we have the model, we can put it together and try to see whether, if there are hazard events occurring, whether we actually see anything happening on the system level. And then we went a step further. Instead of having the probability of events constant, we actually tried to intensify it. And again, the theory here tells that if floods do intensify, there is no time to recover, for the market to recover. So, and eventually you sort of start to trigger different types of feedbacks in the system. So suddenly it becomes, as prices drop and people start to not like to settle there anymore, there is sort of a different feedback that has been triggered. So, and that's what we tried. So we applied the model also to 2 different towns, coastal towns now, and one was with just about 6% of houses in the flood zone, and another one was with almost 50% of houses in the flood zone. And we were tracing, and we used this Bayesian statistics estimated from the data to guide the learning of the agents in this market. So they would understand if there was an event happening, and they would update, and they might switch to a different heuristic as well, depending on the ones available in the survey data. Yes, please.
Was Greenville and Beaufort part of the cities that were in the original survey?
They were in the original. So the original survey went actually through the 8 states in the US, including the one, so we ran it just after the Hurricane Harvey, including the one in Texas. So we had the people in the survey, not only, so these 2 towns are in North Carolina. There was no flood event recently there, but we can compare, but the decision rules that were extracted were from the entire sample, or sample of 8 states, so including the people who did experience flooding just a few months before that.
How come you decided to use all 8 states instead of just, for example, North Carolina, or just people from those cities?
Because we did not have people with immediate experience of flooding in North Carolina. So, and we also suspected that probably, so it doesn't matter that much in the US, so in which state you are. I mean, they were all coastal states, they were all states experiencing hurricanes once in a while. So it was the eastern, southeastern part of the US. And so we didn't have any reason to assume that the people would behave differently across states. So, yes?
So is this the theoretical model you mentioned?
So it's still the one model, so I'm just trying to show you the evolution of how we went in the quest for data for this model.
Yes, but is this what you consider the theoretical part?
That's not theoretical anymore. This one is quite, just let me maybe click to the next slide, because I think I have it there. So this is already the model that has the census data, that has the semi-structured interview with the types of how the sequence of actions and interactions. It has the market data to specify expectations, and it has the learning from the data. Yes. Yes, please.
So I was wondering, so that these Bayesian rules, how do they relate to the rules from previous theories, like prospect theory?
So we did. So a great question. Thank you. So at this stage, so we did use the theories when we didn't have the data. When collecting the data, we actually tried to put in the survey measures related to different theories. And because we were also interested in a change, so the households could either perceive or not perceive risks. So we ask questions on whether they perceive risk, and if they do, whether they are willing to stay in the same location or not. And if they do want to stay, whether they want to at least buy insurance, something like this, right? So, or whether they want to move. And so when we were running already the fully empirical model, there was no any more prospect theory, there were expected utility. We just used the empirical rules in terms of how, and these Bayesian rules practically dictated, so depending on when people were updating when events were happening in the model, the agents were updating their probabilities, and they may switch from one decision branch to another. And the decision branch was already, I stay and I don't do nothing, don't do anything, sorry, I stay and I buy insurance, or I leave.
So the Bayesian rule was just the change in the probability to go from one decision rule to another.
It would switch values, yes, yes.
Yeah, I have a question. So these are results of agent-based model.
This is, yes.
Can you briefly explain the graph?
Yes, I will, yes. Yes, but is there anybody who has still a question before I go into the graph? Yes.
And risk questions would like questionnaire or something like those would things with some modeling.
Could you say once again? So,
is this questionnaire contain any kind of games?
Game theoretical, strategic behavior. Yes. Yes. Of 100 once 100, you're very right. So when we were running lab experiments, we went through a very straightforward, very regulated procedure to how to elicit risk preferences in the lab experiments. But that was an experiment that lasted 2.5 hours or so, or 2 hours. In the survey that had to be within 20 minutes, that was not possible. But there are, luckily enough still, these surveys are run for many years already, like in the last 20 years, there were many surveys run of this type, and there is already a specific formulation of the question that allows you to of course, to elicit so whether the people are perceiving risk. It's not the standard risk preference in the sense of the curvarity of the utility function, but it's we were also relating here further to the Slovich work on risk. So he's a psychologist, and he was also, it's not anymore about rational judgment about probabilities. Is it once in 100 indeed, do I perceive it like this, or do I perceive it like once in 50 years? But it was about, do I perceive risk or not, and do I fear risk or not? So do I have a feeling of worry about that event? So, but it was quite standard in the survey literature. Yes. Did you have any questions, guys? Or otherwise, I will just go on with the graph. So, when we had the model packed with data, we could further then run, and we had these two cities, the one where we had almost 50% of properties in the flood zone, and the one where there were only about 6.5%. What we did do here as well, we had just a flood happening 5 years after, immediately, more or less. And why? So the thick lines represent the average across multiple runs, and the uncertainty intervals are so huge because it was a Monte Carlo run, so you had everything we didn't know, we randomized still, try to see whether we still can find any statistical difference between the average curves, right? So, and what we do see here, we are plotting the prices and how prices change. Here they drop in the flood zone after a flood event. And what we do see that in the city there is actually where a lot of flood properties were there, and people, and given the survey data, if the agents experience the hazard event, they will try to avoid this zone. So what we do see that there was an outflow of people from this area, or outflow of demand from this area, meaning that prices did drop eventually. And after the second flood, they actually did drop and they wouldn't recover anymore. While in the town where the share of properties in the hazard prone was rather low, they would still recover over time, right? So, and then we did also a lot of other analysis on the output data. Like, for example, we wanted to see who are the people who are the agents, of course, who are staying, and who are the, for example, on their socioeconomic status, because obviously, if prices are dropping in the flood zone, it means that it becomes cheaper to live there. But if it becomes cheaper to live there, it becomes more expensive to live in the safe zone, meaning that actually households with lower incomes were priced out of the safer areas, and that you could observe it in this settings, in this case, and not in this. Yeah. But that's just to maybe. Do I have half an hour or how much?
You have
1 hour. Okay. So we go to the lake from here. So, so I would like to stop with this example, because for me it's not about maybe trying to explain to you what happens necessarily with this flood case, but in terms of how we use the data and where and what type of data was helpful in either specifying the rules of action or interaction, and where and which data wasn't helpful and where. But I would suggest that we move to another example, and we return back to the different types of data at the end. And the other case was about also related to climate adaptation, but it was another type of hazard. So we were looking at droughts and how farmers perceive them and whether they do anything about that. And it was happening in two projects, one with Rihanna van Daan, and she was a PhD, and it was in the Netherlands. And the other one was with a colleague in the US, and it was about winemakers in Australia. And Australia, of course, is very drought prone as well. So, and we used two different types of data sources in two projects. So in terms of what type of, so coming back to this picture, so the types of data we used here were primarily also on the micro level. And we tried to, so we of course we almost always have this. We try to use as much of available data as possible. But in the case of the Dutch farmers, we used the survey. In the case of the Australian, there was not a survey, but it was a series of participatory workshops where Sondos, my colleague, she had been trying to elicit cognitive maps. So she was trying to map the cognitive process of the farmers individually as well as as a community. And then we were translating that into the agent-based model. So obviously, this was quite quantitative, this was very qualitative, and there was a pathway of trying to make the use of this data in the formal model as well. So, and I'll tell a bit about this. So first about the Dutch project. So here we were looking at the part of the Netherlands, which is along the coast, where a lot of farmers are located, but the problem there still is, so it's because of the water scarcity. So there might not be fresh water available. So meaning that there is only salty water. And so Rihanna did run a survey across among farmers, and trying to identify all sorts of different parameters that could be useful. This survey was quite guided by the theory choice. But I think the different from what, so the only thing which I would like you to pay attention here is that we were trying to also understand what is the social network and whether farmers were actually communicating with each other about droughts in this case, because we were trying to understand, do they understand these risks, and if yes, what sort of adaptation measures they take. And we know that also the diffusion through social networks was a very important point, but we didn't know what social networks are in this area. So we were trying to elicit who is connecting to whom through the survey. So there was a quite predefined set of questions to try to understand what farmers, so these are just the survey articles if you're interested to understand a bit more about this. And the agent-based model. So then there was an agent-based model coded with the parameters such as farm size, income, the types of crops, and the types of adaptation options preferred on the farmer level. And on top of that, we were interested in social interactions. It was also partially because we have chosen the consummate approach to specify farmers' choices. Is there anybody familiar with this theory of van der Jager? So it practically tells you that, so for us it was convenient because we had to communicate between economists and non-economists. And what consummate practically tells, the theory tells you that there are 4 possible choices, strategies a person or an agent in this case could take. The one is when, and it depends, the choice of which one you pick depends on whether you have what's your satisfaction about the situation, whether you are satisfied or not, and whether you perceive that the uncertainty is high, so you do not have enough of information, so high uncertainty, or you are very confident about your choices, you have almost full information. When you're unsatisfied and you need to make a decision and you have a lot of information, then you go through with deliberation strategy, which is actually the rational optimizer in the economic terms. So you have full information and you put a lot of efforts in trying to find the best option possible. However, you could also have, but for example, if you are rather satisfied, and you just repeat whatever you have been doing, right? So you could also imitate your neighbors, either from your close circle or just have the social comparison across the entire population. So in this case, because here the social interactions, the choice of these 2 strategies depends on the social interactions, we needed to understand who are the other actors these farmers are communicating with. So that's why in the survey we were trying to understand with how many do they actually discuss a particular problem. They were given a choice to describe these 5 friends of them, and we were trying to elicit what are the similarities between the particular respondent farmer and the other farmers, so that we could reconstruct in the artificial population in the agent-based model, we could reconstruct the social network endogenously, meaning that if there is anything changing on the farmer's side, the network ties can also change as the model runs. So eventually from the survey we found out that several attributes were, that the farmers who linked to each other were the ones that were doing the similar type of activity. So they were using the similar technology, obviously. So they were connected on a distance. There was a particular radius after which they were not, the influence was not anymore that high on the drought adaptation discussion for them. And they were also different in terms of whether they were more the innovators or whether they were more the followers. So, and eventually we calibrated the social network in the model using this data, and then we ran it. And there is a lot to say about the model, but I just wanted to show you just one obvious picture, which is probably many of you know, with the diffusion. So we were trying to trace the diffusion of adaptation actions in this farmers' population. So this is the average diffusion curve for the optimizers. So if all agents in our population will be optimizers, independently of the climate scenario, what we see is that immediately they all switch. But of course, that's not how the usual S-curve looks like if you ever have read anything on diffusion. And, but however, if we do use our consummate farmers who would be changing across, swapping across strategies and would be relying on the social interactions, we would be getting the curves that are more realistic, I would say. So, and the steepness of the curve would also depend on a particular frequency of hazards. And you could also see that, so this was the average across multiple runs, but you see that the uncertainty intervals are rather high in this case because only few farmers would experience really a lot of loss in a particular year. And there would be the social, even if they were quite influential, they might not, the diffusion process was rather slow. As soon as they happen more frequently, there is sort of also social amplifications because more of them jump into this, into the adaptation because they observe that the farmers who are adopting are more successful. Are there any questions at this stage about this? Because then I would like to switch briefly to what has been done with Sondos when we use the cognitive mapping in the specifying in this case the rules of actions for agents. So each of this type of data could be useful for different types of for different elements in the model, of course. So here the question was about farmers, winemakers, so the vineyard owners, and who would also experience those droughts, and whether they would perceive or not perceive the risks, and whether they would switch or not switch to a particular adaptation option. And well, practically from the participatory workshop, so what Sondos would get is already if she would already process it, it would be a cognitive map. So there will be a lot of boxes. That was, for example, for one farmer only, with trying to capture all the different aspects that influences his or her decision. So was, of course, coming back from starting from this, coming to a formal model code would be a challenge, obviously, because you also, for example, could get 20 of these pictures, they would differ. So the process was, so we actually tried to go through this data, for rather qualitative as well, into a formal code through a range of steps. So first she was trying to, Sondos was aggregating more or less and trying to identify the similar points of decisions in the maps, in the cognitive maps. And based on that, we were constructing a sort of a UML diagrams. I don't know whether, did you go through UMLs? No. So it's practically, trying to draw the sequence of boxes and arrows between them that would denote the modeling steps in the code further. So we were trying to go through, let's say, for me, unorganized in sequence set of boxes and arrows into the one that would be, let's say if we are starting from a time step 1 somewhere in March or so, throughout the year, what are farmers, what are the types of steps, what are the steps the farmers were going through, and where would anything related to, let's say, to droughts in this case, would influence their decision, and whether anything related to social interactions will influence their decision. And that's what we did. That was quite an exercise, I would say, but we were very happy with it eventually. I will, if there are no questions at this stage, I will just jump into the third example and then go to the summary, and then hopefully we can also discuss a little bit also what you have in your what side, maybe with what type of data you are going to work with, and whether there is anything I can reflect on. So in the third example, that was about the role of households and their behavior, their change in terms of energy use in the individual household level, and what sort of cumulative impacts that may have for the transition to green economy in general. And that was, so we I worked here with the PhD student Leila Niamir. So Leila was looking into, we were looking here at the 3 types of decisions households can do on their own. So you could, in principle, invest in something like solar panels, like a big investment like solar panels, so insulation of your house, or you could just buy, I don't know, a triple plus A fridge, right? So that could be rather small and non-invasive versus rather invasive and more significant. You could also just change your habits. That practically costs you nothing, but you probably need to switch off the lights when you leave, or you may want to put your thermostat. So we ran a survey in Spain and in the Netherlands. In Spain it meant that probably people had to be a bit warmer temperatures in summer than they would prefer. In the Netherlands, it's the other way around, a bit colder temperatures than they would rather have. And you could also just switch from your gray electricity provided to green, in principle, as a household. That all of these 3 types of actions would influence your CO2 footprint. So, and Leila was also looking actively at different psychological concepts behind trying to understand what is the process of decision making if you want to include a lot of, more cognitive side of this. Because what happens a lot in this domain is that it's expected, so in a lot of, when policies are designed, of course, it's usually rather economic models that are used to quantify the consequences of any policy decisions, where agents there are quite perfectly rational and so on. There are no biases. And these models overestimate the diffusion of any of these practices. So there seems to be other sort of barriers that are on the behavioral side that prevent people of taking the optimal decisions as models would predict. So that's why we were diving a bit more into the psychology of this. So, so Leila was trying to understand how, for example, knowledge and awareness influences it, whether that leads to, whether it matches any of the personal social norms prevailing, and then, of course, your socio-demographic and income and so on, and what type of housing you live already now, and whether you have enough income to do anything about this. And then the question was, do they undertake or not any of these 3 decisions or them in combination? And we ran also a massive survey in 2 countries trying to identify these qualitative concepts as well to parameterize. So in this case, what we did, we in fact were primarily looking for the parameters and trying to understand the rules, and we used the survey and the census data. And it was only one-time survey, so we really had only one snapshot. Although we did try in the survey to identify what they have done in the past few years and whether they are planning to do something in the next 2 or 3 years. That's of course a bit, it's not the actual data, it's just stated preferences. So it's just what they hypothesize or remembered they would do. And so using this household surveys, we again, here I would like to pay your attention at the, so with the rules of actions and with the parameterization, how the data may play out differently. So of course we were trying to use the survey data to then to run the model where households will consider different choices. And we ranged from anything, trying to see whether it was, so we started with a baseline model that would be a proxy of the rational optimizer with full information, and we would gradually, let's say, add economic heterogeneity, then we were adding behavioral heterogeneity, meaning all these awareness and norms were playing a role. And then we did include, so the learning was rather primitive in the sense that it was just, they were exchanging, agents were exchanging information about knowledge and awareness with their nearest neighbors. So because in this survey we didn't really have information on the social networking details. And we also, so it was modeled in a rather primitive form, so I want to put a lot of attention on this in terms of data. But what we could do, we could try to understand what are the diffusion curves, and you could see under different assumptions on behavior. We were also trying to understand how the impacts are distributed across different income categories and across households living in different types of housing as well. And what we were also interested is trying to understand for the region as a whole, so it was on the provincial level of a province. So if people indeed behave like this, so if we know everything about, well, roughly, if we know something about their awareness, knowledge, and the norms guiding their decisions, what would be the cumulative impacts of these behavioral changes on the regional level? So in other words, how much CO2 emissions can be saved over time under each scenario? What would it cost these people, and who is going, on which side would the costs be? So we could now quantify that. So starting from the survey data, which was rather still about qualitative concepts, with the agent-based models you could actually quantify quite specific variables that are relevant in the policy decision domain. What further important maybe thing to mention is that using this survey, the household survey now that would have the traditional socio-demographic characteristics plus the behavioral part, we could link this survey further to the traditional census data, let's say Eurostat statistics in this case, so we had it for Europe, and in this way we could scale up. So because what we did notice, what Leila found here is that diffusion of different behavior change options would be not that much contingent on the income, as was probably the first assumption we had. For example, you could probably assume that, of course, investing in solar panels would depend on income. But it was actually not the income which was a decisive variable in this change, but it was education and age. And that means that if, for example, we want to understand further for the impact of behavioral changes for the entire Europe, let's say, of course, we only had 2 surveys, so it was a bit a stretch to scale it up, but methodologically, we just wanted to test it as a pilot methodologically. We could have it with the agent-based model, with the survey data. We could use the population projections and the Eurostat projections on how different provinces are shaped in terms of age and education. And then we could sort of scale up the behavioral patterns along these 2 variables for the entire big region, which meant that we could also estimate, so we only had the survey from 2 provinces in Spain and the Netherlands. We could estimate what happens in terms of what sort of preferred actions agents were taking at the country level. But we could also further understand what happens in different European regions. So I would like to mention one caveat. Of course, we had to assume here, we use something like a cultural score to use to scale up the patterns that were in the Netherlands for several Northern European countries, and the patterns that we had for Spain for Southern European countries. But obviously it's much more complicated. So, but in principle, if you have more survey data and you could connect it to the census, you could scale up whatever behavioral part you had in the survey through the model into much larger areas over time. One more last thing which I want to mention on this energy case is that with another student, with Hannah, we had a bit a different experiment with a similar energy model. So the question here was that I would like just to put attention to parameters. There was a bigger question behind in the whole exercise. It was more about how do we use qualitative concepts from behavioral theories in the formal code. But one of them was related, and we were trying to understand how all sorts of differences that come from the way you use architecture, the model, like the sequence and the equations you're using, the different factors that you do include or not, and how you specify them, even income. When we talk about economic factors, it could be about income or a payback period. It's two different things, and how you specify was important. But here I would just like to pay your attention at the different underlying distribution in the data that we tested as well. Because very often, in this case, for example, we didn't have all the data we were interested in on a particular parameter, and parameter here was, we had a participatory workshop, and from that it was quite clear that in addition to the traditional economic and, I don't know, environmental ambitions households may have, what was extremely important is the availability of information. So, for example, if households would have an informant who would actively go in the community and talk about all different options they can take with solar panels, the diffusion was much more active. Went much quicker. But so we were a bit struggling how to put this information and the availability information in the model. And we found only one study done in the US that had information search costs or something like this delivered from the survey. But all what this study reported was the mean and the standard deviation in terms of how much time people were spending in that survey. So there was a paper published about the survey on a similar question, so about solar panel installation in the US, and they were reporting the mean and the standard deviation of time households were searching for information about the products before they were undertaking the action. But of course, what we did not know, what is the distribution behind these numbers. And what we did test, so of course you could assume that everybody had spent more or less the same time, or you could have assumed that it was a normal distribution behind this data, or you could assume that it was skewed. Or we were trying also to extract further from what was published in the paper, so they were presenting a bit the graphs on how it was distributed across the respondents. So what we did do, we ran the model, the same theory with the same data, just the distributions were different. And what we do know, and here we are reporting again the diffusion curves of households undertaking or not this action, which was PV installation. And what we do see with the same data, depending also how information was implemented in the model and depending on the distribution of data, you could actually get very different diffusion rates. So you have to be very careful in this case. So it's not only about knowing the values of parameters, but trying to understand how this data behaves in fact, because your results would be different. In this case, they could vary anywhere from 50% diffusion to 100, depending on how you implement it in the model. So it's just to be cautious about this. And I would like to finalize a bit maybe the talk. So I would like to go with the summary a bit of what we have learned in our team using different types of data. Of course, when we talk about census data, any sort of aggregate secondary data from the literature and how it was used in the agent-based model. So especially with the census data, it's very convenient because it's already available. It's traced over the years very often, and there are standard ways in the ABM literature to disaggregate this, to instantiate an artificial populations based on the census data, for example. So The limitations is that you do not very often know the underlying distribution of what stands behind the averages. And sometimes it's also difficult when you imagine different types of data. So for example, you may have maybe some sort of value survey done in 2016, but you have something else from 2012. And things may have changed, it's not the same population, so you might want to match it a bit carefully. Of course, on the second type of data, with semi-structured interviews, we had a very good experience in the sense that they provide a lot of insights into rules and interaction structure that shape the architecture of the model. So it's this qualitative narrative that actually allows you to decide what would be the sequence of actions in your model. So it's very important because it goes much further, it provides much richer information than any theory may. But it can also help you to follow up to decide how to follow up with more thorough data collection, if you like. But of course, it's a bit subject to interpretation because so you're talking with a person on the go, so there are a lot of open-ended questions, so you have to interpret it. And very often it goes with a limited sample. And in my case, where I had to deal with this low probability but high consequences events, so you're talking probably to, I think I spoke to 4 people, and Kun also spoke to another 3 or 4. So we only spoke to in total with less than 10 people. So they might have not, and these are realtors. They of course had an overview of the market, but still it's very limited within their time scale. So. Working with market data was also extremely useful in the sense that it's already readily available, it's collected, it's very micro level in the sense that a lot of attributes are recorded as well with the price information. We could also use the traditional statistical analysis used by economists, for example, with hedonic analysis, practically regressions. So you could compare to also the outcomes of the agent-based models with the non-IBM work. It was extremely convenient because we had to deal with a very heterogeneous product, meaning that the price would differ from house to house depending on its attribute, not necessarily depending on what happens on the agent side, just because one house had more bedrooms than the other. It had nothing to do with risk perceptions, for example, or learning or anything else. So we had to extract, differentiate the things which were important, the factors influences prices, that are related to our agent behavior versus the ones that are just structural. And having this market data was extremely convenient because we could exactly estimate the effect of different attributes. But the limitations was that it's just a snapshot of time. So let's say if, so this is the typical, this price discount over time which was shown. And imagine if the survey was run at this stage, then you will find the discount like this. But if it was accidentally run a few years later, it would be different. So it's sometimes, oh, sorry, not the survey, the market data. So, so we have to make sure that this is still, that it's a moving, it should be a moving analysis, yes.
I have a question. Going back to the first example, would it have been possible for you to get data on the housing prices and then match that with like the address and then the person in the household that lived there? So you get like, well, I don't know if that's probably too complicated, of course.
It was the privacy issue. So we had all the data on the prices, all the attributes of the house and the exact address, but we didn't know who is the owner.
Yeah.
And we also knew only the time when it was sold, but we could not, and sometimes the same property was sold several times over the 70 years, but we didn't know who the owners are. Of course, for privacy reasons, it's not available. In the Netherlands, it's not even available on the house level. It's only for the postal code area. So we cannot even trace a particular house. So with the lab experiments, so what I loved very much is that you could actually have data on the micro level, and it could change over time. You could trace choices over time, which was very exciting. What was limiting is that adding empirical features was quite constrained, at least in the experimental economy, so economic experiments. Maybe in the experiments run by psychologists, but so I had a psychology colleague, and we were on one project for already half a year, and then we discovered that psychologists actually do not run those experiments over time, at least in the type of psychology he was doing. So meaning that for me it would not, so there are constraints in terms of, there are disciplinary rules in terms of how experiments had to be set up, which means that I think maybe field experiments are much more interesting in this case, or also virtual reality experiments when you could actually immerse people much more in the realistic settings. I think that has a, at least for the type, if the goal is really to get more data about the real world, then I think you have to go more to the real world. If the question is about testing theories, then I think experimental lab experiments are excellent. So it's about, again, about the purpose of what you want to do with this data. And in terms of surveys was something what we used most of all, and for a reason, in the sense that it could provide a lot of data at the same time. It could align very well. You could use the same theory which guides your model design, so it will be very consistent. But the problem with it, it's again only a snapshot in time, and you could see that, for example, that was about a sentiment, a political sentiment in that paper. So that changes very dramatically over time, and if you happen to run your survey somewhere here, you will get a different picture than here. So it's surveys, ideally you would have, if it would be possible to run surveys in a very consistent manner over years, that would be the best source of information. We don't have the luxury in social sciences to have this always. In terms of participatory work, I have most experience with these cognitive maps, and I think that was an excellent tool to extract information on the rules and learning and dynamics. You could also learn a lot about the interactions, which normally you can hardly learn from anything else. But it remains quite qualitative, which means that in our case, for example, ideally we would love to have a complementary data collection. For example, we didn't know necessarily what were the thresholds. For example, farmers were reporting that, yeah, but if the damage is too high, then I will switch. But too high was not, what was too high for that particular farmer was not recorded during the interviews, because it was already anyways a very rich discussion. You only realize sometimes only post factum which things were most important to follow up. But if you could have a follow-up on this, that would be wonderful as well. And in summary, I would say that I started, when I was a PhD, I had a very toy model during my PhD. I worked with a very toy agent-based model. And after PhD, when I first got my first grant, I thought, well, I'll go empirical. And that was the one where we had with the floods, with the market data and the lab experiments. And then I had to admit, like 4 or 6 months in the process working with empirical data, it was a very different experience, in the sense that a lot of things that you wanted to do might not work because the data limits you. You may not be free to set parameters in the theoretically convenient way or the nice, elegant solutions, because just your data dictates different. So it was a learning curve and a steep one for me. But I still love very much combining data with agent-based models, and I think it's quite important. And I think that the whole process, when you go from a very theoretically elegant, stylized agent-based models towards more empirical on whatever range you stop, is extremely important, because the value of models is not only about testing theories, obviously, but trying to help us explain the empirical phenomena we're observing, and especially if it's the one that no other approach can explain and you could give an added value with agent-based modeling. That's, I think, where the biggest strength of the method is. So all in all, I would say it's extremely, I'm a big proponent of using data to justify, in agent-based models, either to justify micro foundations or also to try to reproduce the known macro phenomena that might not be always obvious with other approaches especially. But I also think that it's a win-win situation in the sense that you could use agent-based models to help increase the impact of the data that you have at hand. Because very often we collect data on a very limited sample, even if it's a sample of 1,000 people in the survey, it's still a small sample compared to the millions of population that we usually deal with when, well, let's say, or policymakers deal with when they have to make decisions. So if you want to understand how this data plays at a larger scale or over time, given that that's how the behavioral patterns elicited in the data, in the small sample data, how they behave on a larger scale or over time, I think the value of agent-based models is just very high, and it's a great marriage in that sense. And I think it's also in both you could try to help to understand what are the real-world scenarios given these dynamics that ABMs can provide and these insights, empirical insights that data can provide. And you could also, of course, stress test theories and help develop them further. So it's not only the application side of it, but also the development of the science. And with this, I would like to finish and just to give you, to maybe share a little bit that in the next project, so what I'm interested to do is really to try to understand whether we can actually have this micro level surveys. So trying to have surveys over time is my next adventure in terms of trying different data. And with this, I would like to thank you also, the teachers and the students I worked with, and I would welcome any questions from you.
So thank you very much, Tatiana, for this brilliant lecture. Do you have any questions? We have plenty of time to talk.
So, I understood from your lecture that you were constrained in terms of the data, like the data constrained your research.
The last comment I gave, yes.
Yes.
Yes, yeah, go ahead.
Could you comment how much you felt like constrained by data when you were posing the research questions initially?
How I was constrained by data when posting the research question. Let me maybe clarify what I meant. So I think if you start with we very often start with the toy model at the beginning, right? So because we want to make it simple and transparent and manageable, and we might not even know what type of data we need. So it depends on the question. But we have a clear research question usually in mind. So we're interested. There is something in the real world that triggers us. There has been already some research done on this, but not fully explained. And then you want to make a next step further, and that's the research question that you're posting, like why there is this abrupt change, or why there is inconsistency in the real data compared to what theory predicts, for example. And then you try to, you may happen to choose agent-based modeling as your research method. And then that was at least the path for me. So, and first, for example, when I start with the urban economics model, it's a very straightforward theory. You just have preferences, you have budgets, you throw these agents, they interact. I can have them with different budgets. I even can have them with biased preferences. But then, for example, I get data on the income distribution. And what happens, what may happen is that I do not, there are just no trades happening anymore because it becomes unaffordable. So I have, in the way I have constructed the model theoretically. So that means that I had to revise each time I was adding any data, I had to revise it's not about just plugging a parameter somewhere or replacing three lines of code which was driving some dynamic in your toy model with an empirical function. It's not like it doesn't work like this. That's what I think I tried to say. You have to revise the entire architecture of your model each time because there might be inconsistencies. You might unconsciously insert inconsistencies, or you might not have or it just becomes sometimes computationally more costly. For example, for me, if I just went, so the first models I have been playing with, I had just a grid of cells, they were all equal. When I had the empirical data, I suddenly had to work with polygons of different size, and I had to so there were computational challenges to this as well. So that's what I guess. I mean, I didn't mean that the data constrains you in what you can, in the bad way, but you have to make sure that to account for the fact whenever you work with data, there will be extra difficulties. That's what I think I was trying to say.
Like for example, would you abandon a research question when you would find that there are no data available or it's very sensitive to get this data?
I would not. I guess maybe there might be, I can imagine there might be research questions which you need to abandon, but in my experience I have not faced it. For me also always the research question was quite clear, and even if there was no data available, like at the beginning, like we didn't have the survey among buyers and sellers in this flood example, so we just use theories then. We don't have the data, but we know how on the market level, how on the system level, what the phenomenon is. So so that this price discount should be that size, and that it drops. We know that. So then we try to understand. So which theories could explain this better? And there might be maybe even more to this because maybe there was something with interactions we didn't guess right, but we can always test it, at least theoretically. So I would not, I think if you want to really make an agent-based model that is fully empirical, you probably need to reproduce the reality, and that's not useful anymore because the model is so complex that it doesn't tell you, it's less controllable, doesn't tell you much new. So you might need to make shortcuts, and that means that you probably won't have data on some parts. That's my personal opinion, so not of the school. Yeah.
It's quite shared. It's
Quite shared.
Anyone else like to ask?
Yeah, actually has a lot of questions, but let's start from the so yeah, I totally agree with what you said, that in psychology we do not have, well, or we have like plenty, dozens of theories, but very few that are properly formalized. So my question is, how do you go from the process of making a survey or from the mind maps to the formalized version of the motivation or whatever else you put in the model?
That's a great question. So I love psychologists. So I work for several years already with a friend psychologist, and at some point when yet another master student was using theory of planned behavior in this case, he already told me, you know, Tatiana, that's all very nice, but honestly, this theory smells dust in psychology. Nobody's using it for 20 years already, so why in the world do you use it? And that made me realize that actually a lot of theories that we do use in the modeling literature are not the state of the art in behavioral sciences. And there is an explanation to this as well, because probably some 15 years ago there was an agent-based modeling paper published using this theory, then another one. And if I'm choosing now some theory to explain human behavior, I'm reading this literature, I'm familiar with this theory, I pick it up. So there's sort of a path inheritance in these theories. which means that also modelers do meet the state of the art in behavioral sciences. Another point, maybe what I learned, I don't know whether it's true or not, so you are better to judge, but my understanding is that if you want to earn a PhD in psychology, you roughly have to invent a new theory, or at least a variation in the theory, which means that there are a lot of theories coming by all the time in the field. So there is no way anybody else except psychologists could be on top of the latest, but my impression also that some of these theories do share very similar concepts, and maybe some of the nuances that psychologists are studying are not necessarily important for the modeling. But coming to your question, so how do we interpret that in the formal code? That is always a difficult issue, and maybe with this work with Hannah, when we tried to, the paper which was published in Justice practically dedicated to how difficult it is, and I think this is not a process a modeler should do alone, because we do misinterpret psychological concepts. We do our best to formalize them, like we can have norms, for example, as something like a weight somewhere in the function, or it could be if-else conditions somewhere in the code. But we might not still get it right, and I'm quite sure we're not getting it right always. But because it has such a crucial difference for the modeling outcomes, I think it should be a joint venture. It's an interdisciplinary work, that's how I see it. It should be interdisciplinary, or at least having some review by psychologists, whether this is the right way we interpret it or not. Another thing, of course, as well, is that you might, not a lot, but some psychological concepts may not necessarily also withstand a test of reality, not at least in every case. Maybe the process has to be iterative in the sense between theory, data, and models. Maybe you have a theory, you have probably some observation in the data, you create a theory. You want to go and test it with the data and try to see whether whatever you predict in the theory is actually happening with the model as well, if there are anything like dynamics or interactions or learning in there. So I guess it's my general thoughts. So with the, I can go, I think, for long, so and I'm happy also to discuss it over the break, because in each particular case, we sometimes we just use the common concepts that have been already tested, especially if there were already surveys run to measure a particular variable, then we just try to use the same questionnaire. And then it's very often comes as a parameter somewhere in the function. But what I realize, but for example, with participatory work, that's not the case. So it's always very much tailor-made for particular case, for particular set of people in the room. So that was, I think, much more difficult exercise. And it's on the type of information you get there is also very qualitative. So you have to process it probably through several iterations before you can code it.
Okay, so one just
yes.
quick follow-up.
Yes.
So is it always like, or in most cases, like model-to-model process? Like we have like this particular problem and this particular situation, and we want to model motivation, and we model it for the purpose of this particular model. Not using some...
With respect to data collection, you mean? Or with respect to...
No, so for example, the psychological processes or whatever processes that we want to formalize and include in the model, they are based, they're tailor-made for a purpose of a particular problem? Or is there like a general set of, I don't know, formalized concepts that you can include?
You hit on the holy grail, I think, of the modern ABM, social sciences, computational social science. Ideally, so of course, because the whole field is aims to try to understand behavior beyond the perfect rational optimizer, we want to go into more behaviorally rich decision making. And by now, what happens, of course, there are the same theories or the same type of decisions have been reproduced multiple times by different authors in different models. And now the field, I think already for some 2-3 years, the discussion is very hot in the community internationally, is that that's not the way how we can further proceed. Because we already, so the idea is then to, of course, share models and so on with OpenABM ComSysNet is very common. But sometimes you download the model and it's huge code with multiple pages, and you only need that particular part about that particular decision or that particular user theory in a decision. So the idea now is to try to store and share modules representing the type of decisions. Let's say you want to model opinion dynamics. Here are different pieces of code doing that. And the hypothesis is, of course, if we start sharing the modules, only the piece of the code related to a particular decision, the evolution in computational science will go quicker because we could review them better. It's not anymore going through pages and pages of code while we are probably interested only in one paragraph, right, of code. And you could try to see which one, maybe a particular code would be more efficient or more elegant or would reproduce the qualitative concepts better. I think that's now is really probably the one of the main wanted things as at the community level. But it's yeah, there are a lot of debates on. With pros and cons, it's also not the idea that you just plug and play. It's not that you have to, in a stupid way, just copy and paste it, but it's more about the transparency. So this is how 10 different people worldwide have modeled this decision. This is the code. Maybe it has to be shared as a pseudocode because we all may use different languages. Still, the majority of people use NetLogo. Around the world, and but how we specify even the same theory of planned behavior may be specified at least in 3 different ways, as we found out, and they give different results. So, and that's not the way to go. We cannot. I think it's not acceptable.
Anyone last? One last question?
I said a very quick question.
Yes.
With all the examples you showed, what is the time frame for those projects? Just curious, because as a PhD student, we have like 3 to 4 years.
Yes. So there were multiple PhDs.
Maybe just elaborate now on that, because that was one of my questions I'd like to, or at least to have your opinion on that. So I mean, you show here research which requires a list team of collaborators and quite extensive funds for being formed. How many of you are working on funded research project in which you are just a member of a larger team anymore? Some of them. Good. Others are working on a PhD more or less independently. So, I would like to ask you, what do you, what is your suggestion or advice for those of these young scholars who not working on very complex projects in which, I mean, they can, design survey and some quality data and inform them all. How can they, I mean, do cutting-edge research and empirical ABM without being, what is your suggestion for
thank you. I'm very glad this point popped up because I think I made the wrong impression. A lot of the things that I showed were done actually within a scale of one PhD project. What I just showed was I packed them together to try to show you different examples. For example, with the farmers, Rihanna ran a survey and she did a model. Of course, I was very actively involved. So it was a bit about a PhD and a supervisor as a team. With Kuhn, he did a survey and a model himself. Hannah was even a bachelor student, so it's a bachelor student, right? So it was half a year or less, it was 4 months, but she was lucky that we had a project within which there was a participatory workshop run. So with the Australian project, it was a team, right? So, but I'm just trying to say that it's manageable within the extent of one PhD. I'm not trying to communicate that you need to do all and you need to collect all the data. I'm just trying to show you the different examples and the different type of data that has been used for different purposes. And not all of them, not all of these lessons would be even useful for you, but I hope maybe some will. And I think you could even just start in simple with using the sense, even if you don't have, I think running a survey is rather expensive. You have to have funds for this. But honestly, when I was a PhD, I even ran something like a role-playing game with a group of fellow friends, right? We met for dinner and we had a lot of fun with the board game. I'm not saying, that helped me to understand, so which of my assumptions that I'm putting in the model, so that was not something what I used as published as an article or something, but it helped me to clear off the assumptions that would definitely not go into the model and the ones that were reasonable to assume. You could get a lot of data now from the literature because a lot of surveys are published. Now with the open data movement, it's a huge movement, and around the world a lot of data becomes more and more accessible also in terms of social surveys. They're being shared more easily now. You don't sometimes need to run it all by yourself. But I guess I'm just trying to say that I think if I did create the wrong impression that you need 10 people and millions to be able to do this, that's very wrong. So you need sometimes just a person who is enthusiastic. Yes, sometimes you need funds for a survey. But for example, the market transaction data, honestly, when I started the project, I didn't have it, and I just read. I was a long-time fan of my collaborator now in the US, Paul, and I just emailed him out of the blue, and I said he was not an agent-based modeler, but he is an economist having this market data. And I said, I'm really, you know what, I'm interested in this issue, and and in your recent publication, you published that there is risk perception dropped, and you know I have the method to study this. Can we have a call? And we literally called. And that's how our collaboration started multiple years ago. He shared the data, we visited each other, we had a student then jointly. I didn't pay a cent for this data. So it was really, I'm just trying to say there are multiple ways of getting to data. And sometimes it doesn't work, so you deal with, then you play with theories. Yeah.
So, I'd like just to enlighten your so when you discuss this idea that sometimes people are really path dependent, so and they are not really on the frontier of researching other fields like behavioral sciences, in which probably or psychology. This is a very interesting point. So and also this probably helps you to understand how much it's very important to not to stick only in your in your disciplinary cave, but try to read or collaborate with people from other disciplines, because this helps you at least not to, picking up an ABM and then relying to evidences or to evidence or findings or a regular approach, which was just quite popular in ABM community, but exactly due to the path dependence of the first guy publishing the opinion dynamic model, got at some point in 2002, I got a vision of an entry point to other disciplines, and then by path dependence, all the people continue to incrementally develop on this kind of assumptions without questioning them, and other specialists around, discovering, offering probably potential findings which could probably help you to a little bit to update your assumptions or keep open to interdisciplinary.
Exactly. I think it's like as any research, PhD research or postdoc or master level is a creative process. And of course you have a limited time, so you need to make sure that whatever you are trying to do is still feasible. But do not limit yourself because you don't have a particular type of data at the moment. I think it's the type of research question, and then reaching out to people from other disciplines, even looking for the data outside in the literature and actively contacting people. That's
yes, the advantage that probably no one of you is doing a PhD in ABM. Do you remember, so some years ago there were discussions about establishing a European level PhD program on agent-based modeling for social science, something very social simulations, something very specific. And luckily, the European Commission did not fund us. Otherwise, we were able to develop specialists of social simulation again, and going on with this kind of path dependency stuff. And probably I'm one fan of having PhD students in traditional kind of PhD programs like in economics and sociology and so on, using ABM. Because this helps to avoid this kind of specialization of really, and this kind of path dependence, which is very, very dramatic, or I mean, at least in my detrimental for the type of research that we do.
I guess it's a research method. So, and of course, you could have methodological innovations and so on, but it's a research method applied to a particular problem, right? Like, imagine like statistics. Like, it's not that you do research on ANOVAs or linear regressions, right? So, as it is, but you apply them to understand a particular process. And I think it's extremely important to talk to the disciplinary group related to the problem you are dealing with within your projects. I think it's extremely important.
So guys, coffee is very close to us, nearby, second floor. I would like to thank you very much, Tatiana, for this brilliant and she's also a role model.
Hey.
Got it? Yeah.
And thank you for the questions and for the active discussions with everybody, especially that corner. And thank you guys for organizing. Yes, sir.